G'day everybody, where's Wally here? Well, Mr. Thrive and Survive, Rich, he wanted to see proof of Penumbra.
The Penumbra, my argument is the Penumbra does not exist. Where the Penumbra starts, even if you start at this very beginning point, it is bigger than the blocking object and it keeps getting bigger as it goes out. This does not exist in nature, at least not with our sun. And that is my argument. The penumbra does not exist, and you cannot show it exists. The shadow never is wider than the diameter of the blocking object. So demonstrate this, SCIMANDAN, or anyone else. Demonstrate a penumbra using our sun and any blocking object.
And yes, Rich, I will endeavour to be polite and cordial the whole way through. But I did find where you made a big derp and you totally screwed up. So, well, I guess I'll save that for the end because it's, more fun that way. So enjoy the rest of the video, and when we get to the end, we'll point out just where you made a mess of it, Rich, and where you got it wrong. Well, Mr. Sensible rose to the challenge and he did such a great job that he inspired me. Well, Rich, first off, you wanted to see penumbra made by the sun. Correct me if I'm wrong, but isn't this annular eclipse from the 21st of June 2020, isn't this all shadow called penumbra? Well, yes it is. Totality is 0% sun, and that's called umbra. 100% sun is called full sun, and that's just a day at the beach, that's fine. And anything that is more than 0% and less than 100% is called penumbra. It's that simple, Rich. Okay, so you asked for globies to do some science, and I thought I should do just that. And when I saw my old mate Mr. Sensible giving it a crack, I thought, hold my beer, Mr. Sensible. So here is the Penumbra 2020. This is the ultimate in umbra penumbra experimentationalisms. It has 4 discs to cast a shadow. So let's go and measure these discs exactly so we know what the diameter is that we're working with. These lids are from my mint jelly jars, so they're all exactly the same size of 66 point... Oh, yikes! So now the 66.7mm discs are at 18, 54, 126 and 270 centimeters respectively. Now for those playing at home, that is a doubling of the distance between each disc each time. So that one's at 2.7. That's at 1.2, 0.56 and 0.18, and there's the target. So the whole beam is 2.4 meters long, 2.7 meters long. So what do we see when we point this at the sun and line it up with the shadow hitting the target? Okay, so I just stood the thing up in the sun and I lined it all up on the little Skywatcher mount. It was probably a little bit too heavy, but anyway, it managed. And I pointed it directly at the sun. So anyway, okay to the data measuring. I just love the way Mr. Sensible did this, so I did exactly the same thing. I too just used the flood fill tool to make a defined edge at a constant level of black-white. It was good to discriminate using that. So looking at DSCN 5259, I rotated the image a little bit to square it up, and then I cropped off some of the rubbish, and then I hit the black select color and I dropped solid color square in the center, and then I did a flood fill of the white paper. The trick is, the first time you do this is to fiddle with the percentage of your film, and you get a good black-white discrimination. But what you can't do is, once you've decided on what percentage works well, you must use the same percentage for the rest of all the other drops. So you're nice and fair and consistent. Then I filled all the umbras as well. And then I drew some red circles to match the edges of the annulus, keeping the X and Y dimensions the same so I know that I'm making a circle. And I recorded the pixel diameters for both the inner and the outer annulus. Then I subtracted them to get the annulus size in pixels. And then I did a neat little trick to figure out the pixel to millimeter by measuring a 3cm scale. And that works out at 8.73 So once I had the inner and the outer diameters, I popped these into a spreadsheet, converted them to millimeters, and plotted that on a graph. Now you see here the orange line is at the 66.7 blocking object diameter, and notice how the penumbra and the umbra both diverge away from 66.7. That's exactly what we'd expect to see. Now let's have a look at some maths. The maths shows us that the umbra will only extend to around 107, 108 times the blocking object diameter when the light source is the sun. It has to be bigger than the blocking object for this to work. Now if you plug this angular size of the sun of 0.53 degrees into a triangle calculator and then set the long sides of the isosceles triangle to 7,200 millimeters, we get a 66.6 millimeter, and that matches the diameters of my blocking lids. Almost. Mine was 66.7, remember? So if you take 7200, divide that by 66.6, add 108 times away, there is no longer any umbra. This is simple trigonometry. And if we look at the ratio of lunar distances to lunar diameter, we see that the ratio for an eclipse just a few days ago on the 21st of June 2020 was right on the cusp of being a total eclipse. And it is easy to see that at apogee you will only get an annular eclipse, and at perigee you will only see a total eclipse at some point on the planet. And just because I like to wind up you flatties, let's have a look at this one. Here's a nice penumbra from, you guessed it, the ISS. Now, if you're on the ground anywhere inside that red zone, when the ISS passes between you and the sun, you are standing in a penumbra cast by the ISS. Now, admittedly, it's a very tiny one because the ISS, even though it's 100 meters by 100 meters, is very tiny at those long distances. But it is still a penumbra. And on that one, it's a couple of kilometers wide. And sometimes it's up to like 20 or 30 kilometers wide, that penumbra, depending on how far away the ISS is. And that is depending on the angle to the ISS, because it's always around 400 kilometers altitude. So yeah, I thought that would be a little bit of fun for you, Rich, to get your head around. A ISS casting a penumbra. And we know it is casting a penumbra because when we're looking at it, we can see it silhouetted against the sun. Therefore, it is blocking some of the sun. Therefore, that is in the shadow that is greater than 0%. Penumbra proved. That's kilometers wide. How about that? Okay, Rich, well, that's probably about it. Thanks very much for letting me come and play with your video and do this challenge for you. I hope you find it educational and that you've learnt something.
Now, as a baseline, I'm using the Great American Eclipse of 2017. This was a solar eclipse that went across the entire United States. The sun was at zenith. The diameter of the moon is about 2,159 miles, and its average distance is about 238,000 miles. You take 238,000 miles and divide it by 2,159, and that means that the moon supposedly is 110.24 diameters distance from the Earth at the time of the eclipse. In other words, the moon cast its shadow 110.24 times its diameter distance to the Earth.
Ah, one more thing.
Oh, just one more thing. Oh, I used to love that show, Columbo. You remember him? I think you're about my vintage. You probably remember Columbo. Remember how the guy would kill somebody and Columbo would come and investigate, and they'd say, oh, well, okay, that seems all fair. So he probably would have come up to you and says, okay, so Rich, you didn't kill the flat Earth after all, did you? And you'd say, no, Mr. Columbo, I didn't, because, 110 is greater than 108. It couldn't possibly be me. Columbo would have nodded and walked out, and then we'd go,
Well, I'm sure you're right about that, sir, and I certainly intend to investigate that possibility. But if you don't mind, I'd just like to poke around your institute.
Why did they state the lunar distance as average? Does that mean that sometimes it's greater and sometimes it's smaller? Did you have a look and see what it was when it's greater and when it's smaller? And you would have said, no, Mr. Columbo, I didn't. And then he goes, oh, okay, that's fine. And then he would have turned and walked and then turned again. He said, wow, it's just got me wondering, what was it on that day when the Great American Eclipse happened? Oh, okay, so it was smaller. It turns out to be 107.1. Oh, Well, then I guess your excuse is gone then, isn't it, Rich? We might have to come down to the station after all. Perhaps you've just killed Flat Earth. Anyway, look, I said that I was not going to be mean, so here's Mr. Sensible to do it for me.
While going through your video, I've been getting angrier and angrier, and I've decided that you are a total...
Well, that's it. I'm done. So, Mr. Rich, Mr. Thrive and Survive, it's all up to you. Let us see exactly what you're going to say about this. You said you were baiting us. Well, we took the bait, and we give you an honest answer, mate. And let's see what you've got. We look forward to it.
So let's see if any of you geniuses who think I don't have an education and don't know anything, so I don't understand it, and so I'm wrong, prove me wrong. I would love to see this, but I bet I won't. And he actually proves a penumbra.
Cheers. I appreciate you acknowledging that, Rich.